What's up, everybody? Welcome back for another video in the series of creating a Wordle Companion App using our Shiny. So in the last video, what we did was we created some vectors that can store some information for us. So Wordle will give us three pieces of information, whether it's not in the word, which is just the regular background. If it's in the word, but it's not in the correct spot as to where you guessed it was, which would turn it yellow, and then if it's in the right spot, which would turn it green. And as you see here, we see that changing. So we start with nothing. Oh, let me bring that back up. So we start with nothing for the A, right? A is in our wrong letters vector. We click on it once, it goes to the wrong position vector, and then we click on it twice and it moves to the right position vector. And all along the way, we're retaining that particular spot for the wrong position and the right position, because all of that actually matters when we go through and filter our word list. So what we're going to do in this video is go in and apply this logic to the existing word list that we have to filter our word list so that we have only words that respond correctly to the feedback that Wordle gives us when we go to generate our second guess. So let's go ahead and do that right now. So to do that, we're going to create a new file, and I'm going to call this new word list, which is going to be a function that takes three arguments. We're going to take our input, our previous word list, and then we're going to also take our response file, which holds all of these three vectors that we have. So let's go ahead and save this file into our functions folder, and let's call this new word list. So now what we're going to do is we're going to read this into our file, so functions new word list.r, so that we can again use that file within our app. So now that we have that, what we're going to do is we're going to create a second data frame, which is going to be our word list 2 as a reactive data frame. And so this is going to be all possible words that we can guess for our second guess within the Wordle. So for that, we're going to use our new word list function that we created. We're going to use input. Our previous word data is going to just be word list 1, and then our response document is going to be word 1 response. So now that we have that, we're going to want to return a value that we're going to end up calling word list. So up here, what we can do is we can start with our word list as just being whatever the previous word list was, and then we're going to want to define our vectors again. So wrong pause is going to be our response document and the wrong pause variable of our response. And then we have wrong letters, which is going to be response, wrong vec, that's what it is. And then we have right letters, which is going to be response, right pause. Okay, so now that we have all of this information, we can use this to then filter our word list. So let's start in the most basic way, and let's just filter our word list. So let's do word list and generate a new word list that is just going to filter to not include our wrong letters vector within our words document. Okay. So now that we have this, I'm going to take one step back and go into our server, and we're going to do output, and I'm just going to call this table. And this is going to be a render data table. And what we're going to want to do is we're going to want to look at word list 2. Okay, so then we just need to add this to our UI, data table output table, save that, rerun our app. Okay, so now that we've got this, right? So with chars, if I try to find a C, nothing, try to find an A, nothing, right? So that stuff is not in our word, but then if I do something like this, the only thing we shouldn't see is an S. So if we search, we see that nothing has an S, but we see that there's E's and we see that there's A's, right? But we see that, this isn't fully responding because this A is in the wrong spot, but we see cared still has these three letters, which are all in the wrong spot, in those same locations. So that's what we're going to go ahead and do now. So we've already filtered our word list to not include any of the wrong letters in our potential guesses for our second word. Now what we're going to do is we're going to go in and actually subset our data set so that those that are in the wrong places are no longer kept in those places as possible guesses. So I'm going to call this separate variable that we're going to keep as keep wrong pause. And this is going to be our wrong pause vector. And we're just going to subset that so that our wrong pause isn't equal to 0. So in other words, whatever's stored within this wrong pause vector, anything that's a 0, we're just going to get rid of it. And so what we're going to use this for is if we have anything that was in the wrong position, so if length of keep wrong pause is 0, then what we're going to do is for I in 1 to length of keep wrong pause So for each of the values that we have within our keep wrong pause variable, we're going to subset our word list such that those letters are required. So grepl, keep wrong pause of I for each of the values and our words. So what we're doing with this is we're creating a keep wrong pause vector, which is in this case just our ARE. And for each of those, what we're saying is that our word list needs to contain words that have an A, that have an R, and that have an E. So we still haven't done anything yet to say that those are in the wrong spot. We've only made sure that those 3 letters are going to be showing up in all of the potential words that we generate for our word to word list. So in order to actually account for the letters in the particular locations and the fact that they're guessed in the wrong spot, we're going to add another filter to the wrong letters that we had before. So again, we're going to grepl, we're going to not grepl, right? So wrong pause of 1 in L1. So if it's in our wrong pause vector, then that means that that letter is in the wrong position. So we're just going to filter so we make sure that our first entry in this, which in this case would be a 0, so it basically gets ignored, is not in letter 1. And then we're going to do, again, this grepl wrong pause 2 for L2. And what this is doing is it's looking here now and it's saying, A, okay, we're going to filter our data set such that A is in the word from up here, but A is not the second letter from down here. So I'm going to copy these down, and we're going to do this for all of the other letters within our guess. So 4, 5, 3, 4, and 5. Okay, so now that we've got this, let's go ahead and run our app again, and let's see what we get. So cares is our word, right? And so let's say we have a C in the word, but it's not in the right spot. We have an A in the word, but it's not in the right spot. And we have an R. And then if I just look at A's, and then we look at all of these, we see that A is not showing up in the second value in any of these. So that's perfect. We've now made it so our data set removes all of the letters that we don't have. So if I look for an E, it's not responding for some reason. There we go. So if I look for an S, it's not in there. If I look for an E, we also aren't going to see anything. E just doesn't want to work. But if I look for an R, A, or a C, that's all going to be within our data. So perfect. What we've created now keeps all the letters that are in the wrong position, but it makes sure that they're not in that position. And any letter that was not in our word is filtered out from our data set. So the next thing that we have to do is just now go through our right position vector. So if I look up here, in this case, we would want to be adding the C to our right position to make sure that our C is in the first spot. So what we can do is, again, up here, we created a right letters value, which is just the entire vector from our response of right position. And we can say if the right letters in the first entry is not equal to 1, so we added the not before our right letters, then what we can, equal to 0, whoops. Then what we want to be doing is we want to take our word list and we want to filter our word list such that L1 is to upper of our right letters in position 1. And the reason why we have to do this to upper is just because our data set has all capital letters for each of the letters. So now what we're going to want to do is we're going to actually want to just copy this for each of our potential words. So 1, 2, 3, 4, 5 for each of our potential letters. So 5 letters. And then what we can do is the second letter, third, fourth, and fifth. And then we just want to change what letter we're filtering to. So 3 and 2. And then again, 2, 3, 4, and 5. So now we're taking our word list and we're filtering it such that each of those letters, so long as they're not equal to 0 within our right position vector, is included in that spot within all the words that we generate. So let's go ahead and run this app now. Okay, so let's say we have a C in the wrong spot, right? So we see this wrong position vector has a C, and we see that all of these words here have a C in them. We go from, let me undo this. So we've got 860 at the start. If I do the C, this goes down to 155, right? And then if I do C in the right spot, oh, we've got an issue. We have an equal sign issue. Word list L1 is equal. Whoops, sorry about that. So we just need to make sure we do a double equal sign so that we have a Boolean comparison, so that L5 is equal to that particular value. Okay, So now let me reload this, lock that guess. If we get C in the wrong spot, again, we see it reduced to 155. If we have C in the right spot, we see now that reduces to 135 words. So we are reducing our word list. So then if I click twice on A, we see that we've now got C and A. And then let's say we've got an S as the last word and then an E. Oh, well, that reduces completely. So for example, if we have in our first guess of cares, C, A, E, and S are all in the right spot, what we see is that CA starts each of the words, ES ends each of the words, and then we just have some letter that's not an R in the middle of the word. So now we have completely created the functionality to recreate or to reduce our word list based on all of the information that Wordle gives us. So I'm just going to go ahead and clean this up a little bit. So we can keep the table there for now. We're going to adjust it for later, but we can actually get rid of this text so we don't generate it over there. And then we can also delete that text output from our UI. So then if we go through and we now want to play around with this, say Wordle gives us that a C is in the word, S is in the right spot, and an A is in the word, but it's in the wrong spot. We see that we go from, 855 or so entries to down to just 20. And we see C is not starting any words, A is not the second letter, but S in all of these cases is the last letter of the word. So now we have this functionality baked in for word 1. So what we're going to do in the next video is go in, copy all of this functionality for all of the subsequent words, and then we will basically be done with our Wordle Companion app. So I hope you guys have enjoyed this series so far, and I hope you stick around so you can see how we finish this off. I'll see you guys in the next video.